Hello, dear friends, and another educational video is at your service. In this educational video, we want to talk about the software Epw1Year, Epw1Year. What is this? This is software that we produced in the previous video using Python code. Well, what does it do? It generates an EPW for us for a desired year. What is an EPW? An EPW is a climatic input data used for software such as EnergyPlus and DesignBuilder, etc. If you don't have information about them, like what an EPW is and such, well, I recommend watching the educational videos of the channel. In the channel's educational videos, in the playlist, hear about EPW, for example, what is inside it, how it is, we have explained in this video. How to download data from NASA and many other videos, I recommend that you see these. This software that, as they say, we now want to explain, was prepared using Python. We put its educational video in the Python playlist section. The production of the EPW file for a desired year based on meteorological data from the NASA site. This is its coding. It is a complete Python project. Well, but in this video, what do we want to do? We want to work with this a bit and see how correct it is, how correct it isn't. So, where is its data downloaded from? From the NASA website. I also put the NASA website here if you want, go and study it. Of course, I have also said that I have put an educational video on how to download the data from the NASA site in the Data Access Viewer section. Okay, let's open the software together. The software is in the exe format. You can download it. I will put its links for you in the description, both in the Telegram channel and, of course, I have already put it in the Telegram channel, and using the link that I will put for you later, you can download it. If I show you its links, it is here. For Windows, you can download it from this link. You can also download it from the Telegram channel, which from here, download. Okay, let's run this together. Because it's written with Python, a page opens and tells you to wait. It depends on your system. It takes 1 to 10 minutes. For me, it takes about a minute, maybe even less for the software to open. The software is written in the Python language, and the time it takes to open is long. You can see that it took about 40 to 50 seconds for it to open. Okay, subscribe to our channel on YouTube. If you haven't done this yet, do it right now. Click on View Related Video and it will come where? It will come to the same video in which the coding was done. This same video that I put here for you. Click on it and it will go to YouTube and open there. Okay, select folder. Where do you want to put the file you want to make? I will create a folder here on the desktop called New Folder. I created a new folder. Okay, I want the data to be poured here. First, you have to select it. If you don't, it will give you an error. Enter the latitude and longitude. Here, it suggests 2 digits, but you can enter 3 digits. 35.69. If it needs high accuracy, you need to enter it with more accuracy. Of course, a comparison of its data has shown that there is approximately a half a degree difference in the data on the NASA site. But if you want more accuracy, well, enter 3 digits. Longitude. This information is for Tehran. For what year do you want? For what year do I want? For example, 2023. The name of the city is Tehran. Tehran, the country code is IR Iran, country is Iran. WMO, which is the International Meteorological Identifier, I said you can search the internet and find it. It's a number. From the Meteorological Organization's site you can also find it. 40,754, time zone 3.5, the height above sea level 1191. These are all C, that is, in meters. Which ones are important? Latitude, longitude, the year you want, the time zone, and the height above sea level. These are important and must be entered accurately. Well, now do you want the illuminance? Because NASA data doesn't have the illuminance, I have compared 3 methods. I found one of the methods, a formula that I have validated, which shows that this method is good for calculating illuminance. So, if you click this, it will calculate the illuminances. If you don't click it instead, it will say missed. It will put a 9999, which means that this file does not have illuminances. Okay, now I will click. I will explain this more later. I click this. We have a button here. Help, which explains from the NASA website, by using this software, you can produce EPWAs for any city in the world for a desired year. Of course, provided that the NASA data is available for your city. You can enter 1900 as the input this here, and by using that find for your location, the data is available from what year. Also, the illuminance data, using this formula, if you check this, it will be calculated. Now I will explain these more. This is its normal mode if you want to perform a production. Now that you hit Run, let me bring the new folder. Okay, there is nothing in it right now. See, New Folder. If you hit Run, depending on your internet connection, it may take 1 minute to 2 minutes or much less. Sometimes it needs a VPN, sometimes it doesn't. I am running it now. Downloading, please wait. Depending on the download, it may take 2 to 10 minutes. First, it downloads its data into Excel, see here. Tehran 2023 NASA RLY, then it generates the EPW. This data you see here is the hourly NASA data. It will give this to you in Excel. It gives the same EPW and this. See, from the year 2023, 1/1 to the end. It gives you a complete year. What does it give? Well, let me enlarge this. Dry bulb temperature, dew point temperature, relative humidity, pressure, the atmospheric radiation in normal direction, horizontal in normal direction, and the rest of the radiation. Types of radiation, infrared, wind direction, wind speed, and we use all of this. We put this in the EPW file. This is the EPW file that is here. Okay, in this EPW file, the first 8 lines are the header, and the rest are the hourly information. If I change its format, 1, 2, 3, 4, 5, 6, 7, 8, 8 lines are header information, and the rest are hourly. I explained how you can see the information inside the EPW. I have put the educational videos. Let me go back to the channel. In the Software, Climatic Data Software section, I have introduced 2 software. One is vTools, vTool. This and one also in the first video in this section, named DView. You can open DView or vTools and see the data. For example, I will show you DView. Now you can see the EPW that we built here. For example, the profile, global direct, diffuse, dry bulb, you can see all of this. Or the software vTools. Okay, so we were able to produce this EPW file for 2023. Now you want to produce it for another year. For example, I will put another year, for example, 2024. Has 2024 ended? On the date I am recording this video, what date is it? Let me show here, August 12th, 2024, it has not ended. But we can still produce this. It will be incomplete, but it is there. If I hit Run, let's see until when will 2024 give us the data. It depends, sometimes it takes a long time, sometimes less. It gave you an error. The file has been produced, but it has less than 8760 hours. This is for information. Okay, let's come here. This is also 2024 which has been produced. Now if I open its Excel, let's see, until where does it have, for example? See, in some places, this is minus 999, that is, it isn't there currently. Until where is its completion, if I can find it. Some data, this data of this EPW file is useful until somewhere in 2024. The information is there, approximately I think the month of May. Let me run it. Let me go back. Yes, until the end of the 4th month. See, it is here. Until here the data is there, that is, it can be done without a problem until here. When will this be completed? Gradually. This data is not yet complete, but we were able to create the EPW of 2024 and use it. Okay. Another point, leap year. If your year is a leap year, it must be in the header file, the section that is there. Let me open this section. Date inconsistency, this, instead of no, it must be yes, otherwise, it will make a lot of difference in energy consumption. Now, let me show you this 2000, for example, 2008 is a leap year. If we run it, then that header file must definitely be written as yes, otherwise, it will make a difference. That is, energy consumption in leap year mode will make a difference. The file is produced, this year is a leap year. It has 8784 data. It was specified in the header file that the year is a leap year. Okay, look, 2008. 2008, the data that it has, how many? 8784, one of them is the header. That is, it has more than the others. The rest have 8761 data. Why is this? Because of the 29/2, which is one more day. It becomes 366 days. We have that also in this year in 2008. In 2007, for example, we don't have this. It is not a leap year, look here, 29/2. This exists and it can't be ignored. Therefore, when I produce the EPW of 2008, I need to have yes here instead of no. The software does this automatically. You just need to know that leap years are in this format. But in the leap year, its EPW is how many? 8792. Why is this amount? Well, 8792 minus the 8 header, 8784, minus 1 extra day of 24 hours, 8760. So its number is correct. In this way, the leap year. But the leap year, I have made a comparison, I will show you. Okay, I have made 2 Epws so that I can see the effect of the leap year. One of them is this 2008. In one, I put no here, and in the other, I put yes here. I calculated the energy consumption of a building. The building has one room that has a window facing south. It is not a complicated thing. I will show you what I mean. This building using EnergyPlus software, I made this. I will put the video of EnergyPlus later, but for now, just accept it as is. EnergyPlus needs a weather file, one weather file. Well, I am opening it here. I will select drawing. I want to show you the map of the building. Hopefully, I will definitely put an educational video on EnergyPlus later. It's a building, a top view. I can rotate it. In the south direction, it has a window, only that, it's one zone. It's a room that, in the south direction, it has a window. All of the simulations that you see from now on will be with this. It's just a test. Okay, let's go back to the leap year. In the leap year, we said that February 29 is present in 2008. We had 2 files. One we put no, one yes. Now I have compared these 2 and I will show it to you. Let me open an Excel. If the leap year is not introduced in the header file, February 29th is ignored in energy calculations. It is recommended that the leap year is introduced because the results will be different. You are omitting one day because, as they say, the energy consumption of today is dependent on the day before and the day before that. You can't ignore one day. In the case where you put no from 28/2, it immediately goes to 1/3. But if you put yes, 28/2, 29/2, and 1/3, it doesn't ignore this day anymore. So, it is important that we definitely specify the leap year. These results that you see here are the daily data. That is, when you put yes, it will definitely consider 29/2 for us. The software does this automatically. Okay, that's it about leap year. Let me see, where have we gotten? I have told you about the software production for normal mode. We have said 2024. We have said that it's incomplete. We have said about leap year. Formulas for Illuminance. Okay, let me close these. Here, if you check the Illuminance box from the formula that I brought here, it will come and calculate the Illuminance for you. I have validated this formula for a few cities in America for which there was Illuminance data. What does it do? Based on the radiation data, it comes and calculates the Illuminances. Based on the radiation data, it calculates the Illuminances. For 3 cities in America, Chicago, Sterling, and Tem, I don't know where this was, these 3 cities were compared, and the results showed that this formula that exists gives acceptable results. I compared 3 formulas, and between 3 formulas, I reached this formula. The formula that is here. What does it say? It says if you want to calculate the global radiation, the Illuminance, you need to multiply 10.76391 by global horizontal radiation by 10.5. This is for global horizontal. For diffuse, it is also like this, and for direct, it's also like this. Where did this formula come from? From this source, the source which I have put the link here. If you click on it, I brought it from this source. How can we convert watts to lux? Read it. If you want, check that box or not. 10.76391 multiplied by global horizontal radiation multiplied by a number that I made as 10 based on comparisons I have performed. If you want to calculate the global, then it becomes global. If you want to calculate direct, it becomes direct. If you want to calculate diffuse, then it becomes diffuse. So we give diffuse radiation here, multiplied by 10.76391, multiplied by 10.5, it gives you the diffuse illuminance. In this way, we have added the illuminances inside the EPW file. This hasn't come from NASA, it has been calculated with the method I have described. Okay, this was about illuminance, and I told about production in normal mode. I said 2024 is incomplete. We talked about the leap year, correction of header. Okay, the header that our file has, if you want, you can correct it. For the example that we produced, for example, Tehran 2008 or the same 2023, our header here, you see, is empty. Design conditions and such things, I have explained these in the educational video. Here, manually, you can add and fill this. Of course, it does not make much of a difference in the calculations of energy consumption. In fact, it doesn't make a difference. Well, how can I convert this? With the use of weather converter software, you can complete the header to some degree. What things does it complete for you? I think it completes the typical extremes. It also adds the ground temperature. It calculates it itself. Weather Converter is a software that comes with EnergyPlus. When you install EnergyPlus, any of the versions, it doesn't make a difference. For example, in version 8, here, you have a weather statistics. This is what I mean. Okay, I select Tehran 2023. I want to convert it. I can convert it to Excel, or I can convert it back to EPW. I want to build an EPW. I select Convert. Tehran 2023, I name it Converted. It has been converted. I am converting. It is building an EPW for us. It is here. See, this is the normal state, and this is the converted state. Look, it has filled some places. It has filled the typical extremes. It has put the ground temperature. It has also added a comment there. If you want the ground temperature, this gets from the file itself, but the other information does not make a difference. We have also changed this part to some degree. The part that, as they say, we were saying that our data from where it has come from, how much validity it has. But in energy calculations, the way I checked it, it doesn't make a difference. So if you want to fix it, it is like this. Now, if we compare the energy of these two, it doesn't make any difference. We can compare these two with DView, or you can compare with EnergyPlus. The header file, some of the software may be important for them. So 2023 converted, 2023 normal. Let's go and compare their profiles. See, the globals are exactly on top of each other, the directs are on top, the diffuses are on top, that is, it will not make any difference. Now, let me bring a dry bulb. The dry bulbs are on top of each other, the wet bulbs are on top of each other. It doesn't tamper with the data, it only changes the header. Therefore, in the results of our calculations, the energy consumption and these things don't make much difference. If you want, you can complete the header in this way that I said, or you can enter it manually. Okay, what is the next section for us? Oh, let's go to the comparisons. We can download directly from the site and from the software of the NASA site. I came and compared this, validated it, and its result is almost 100% correct. The validation section, we don't say anything. The download that is done from NASA manually and by using this software is completely the same. But the next section, okay, the energy consumption of 3 cities in America. Well, to make sure how correct this is, what the results are like from NASA data, we came and chose 3 cities from America. These 3 cities had EPWs that, when installing EnergyPlus, are in the same folder as EnergyPlus. When you install EnergyPlus, if you go to the folder of EnergyPlus, usually it gets installed in Drive C. If I look at version 8, the weather data, here, you have the weather data of some American cities. From these, I selected 3 cities. The 3 cities that you see here. City number 1, Golden, where was that? Denver, city number 1 is Denver. Okay, the EPW that they have made, they have used month 2 of 2001 inside of the EPW data. They used month 2 of 2001. The second city for its 4th month of 2002 they have used. The third city, that is Sterling, for the 8th month of 2004 they have used. So I came, and what did I do? I said, I came and made the EPW by using NASA data from the software that we have here, for these 3 cities, but for what year? For city number 1, the year 2001, the second city, the year 2002, the third city, 2004. I compared different months. In city 3, I compared the 8th month. In city 2, I compared the 4th month. In city 1, I compared the 2nd month. What did I compare? The energy consumption. What data? For the same building that I showed you, one zone that had a window facing south. Okay, I will show you the result here. The result is acceptable. Okay, This is for City 1, City 2, City 3. It's cooling, see, produced from NASA, a real state which has come from within the EPW. This is its total, and this is the heating. The difference between them is also in percentage. It's very low, between 2 to 5%, and in my opinion, this data is acceptable. Okay, I told about the energy consumption of 3 cities in America. Now, Tehran 2019. We had data for Tehran for the year 2019. We came and compared this. The Tehran 2019 that we have now, that we built using the NASA data with the software, the Tehran 2019 that we had before. Its comparison also shows a difference of approximately 1.64% in the overall energy consumption between the state we had before and the state that NASA has given us. For example, 2019. This is its chart, which is acceptable. Then, to make sure, we came and made the data for Tehran from 2001 to 2023. We had done this before as well, using the data of the Meteorological Organization. That is, we had the data of the Meteorological Organization. We had made 2001 to 2023, 2001 to 2019. Then we came again and did this with this software as well. And again, the results are similar to a great extent. The percentage of the difference is 1.75% on average. See, from 2001 to 2023, using the NASA data, from 2001 to 2019 using the data of the Meteorological Organization, the comparison shows approximately 1.75, that is, approximately 2% difference. These are also its charts, total NASA, total old and linear. Their trend is also similar. What does this show? It shows that from 2001 to 2019, the energy consumption is increasing gradually in Tehran. Okay, this is interesting. This heating NASA, we have drawn the heating, as they say, of NASA here. What does it show to us? If we draw a trend line, it will show us that the heating is decreasing, cooling increasing. That is, you need to cool the air more in the summer, and you need to turn the heater less in the winter. That is, that which they say is warming, it is this. That is, it's getting warm gradually, it's getting warm gradually. You can do these kinds of comparisons. You can produce data year after year for any place you want, any city you want, and with this you can easily give a paper, compare it. Now different ideas can come, and you can give a paper with them. With this software that we made, you can produce the EPW for any place in the world and for any year you want. Any year that you want. Well, not any year. Now if I give 1900 here, hit run, it gives an error. It says it's available from 2001. That is, for Tehran it's available from 2001. According to the region, it is possible that for a city it's from 2001, possible for a city it's from 1990. You must check this every time. That is, if you give 1900, it will tell you from what year the data is available. Okay, but let me also say the errors if you, for example, instead of a number, you enter a text. It gives you an error if you enter strange things, well, it will give you errors. These it will consider as mistakes. With exactly the same format that is there, it has to be used. Don't forget this. We have done another comparison, Tadrij with the south of Tehran, sample. We have come and compared 2 regions of Tehran. One is Nazi-Abad and one is Tadrij. Tadrij is in the north, Nazi-Abad is in the south. Let's see, to what result did we come? The result is very interesting. The result shows that energy consumption is different by approximately 19%. Approximately 19%. The 14 has become negative, that is, approximately 19% less than that of Tadridge. The consumption of total energy, why? Well, it is shown here. The heating of Epw1Year with the heating of, where is it? The heating of Tadridge. Tadridge has very more heating than the south. The north of Tehran, its energy consumption for heating, that is, its winter is much more, but its summer is less, but not too much. In total, it shows that Tadridge needs more energy consumption than the south. In the south, you need more cooling than the north. In the north, you need more heating than the south. You can also do these types of comparisons for different points, for different cities, and see the comparison. Look, for example, this is the total energy consumption, and this is the energy consumption for heating, for Tadridge and Epw1Year. Tadridge shows that its heating is much more, but the cooling, that is, the cooling in Epw1Year is much more. In total, it shows that the cooling of Epw1Year is 72% more than Tadridge. The heating of Tadridge is approximately 100% more than Epw1Year. You can do these kinds of comparisons easily and see the comparison. Look, for example, this is the total energy consumption. This is the energy consumption for heating. Tadridge and Epw1Year. Tadridge shows that its heating is much more, but the cooling, that is, the cooling in Epw1Year is much more. You can easily perform these kinds of comparisons. Well, let me see if there is anything left. No, I think it's done. Okay, this software is free, you can use it. I hope you will use it as needed. Okay, this video has also ended. Don't forget to introduce the channel to your friends. Subscribe, leave a comment. Until the next videos.